Hello friends, welcome you all to the next lecture of the JC eConnect series of online lectures. We are into module 5 kinematics, and today we will be discussing motion under gravity. Any object which is thrown upwards or any object which is falling down comes under the effect of the gravitational force of the earth, and study of this is motion under gravity. So here firstly we should understand what is acceleration due to gravity. It is the acceleration provided by the earth's gravitational force to an object which is moving up or to the object which is coming downwards is termed as acceleration due to gravity. Generally, if the object is moving up, g is taken as minus, whereas if the object is coming towards the earth, g is taken as positive plus. The general value which we use for acceleration due to gravity g is 9.81. So when we come across the formulas which are further listed, all the formulas remain the same. That is your initial velocity term, final velocity term, uv, or time t. Only the difference in these formulas is the acceleration term a is replaced by the term gravitational acceleration, that is g, whereas all the other formulas remain the same. In some examples, as we have to calculate height, the distance term, which is small s, can be replaced by h. Other formulas remain the same, which you have been studying from your school or you have studied already in PUC and applied these formulas in the previous sections of this module. So firstly, you should be knowing these formulas before starting the examples. Secondly, what I want to tell here is, don't take these videos as just an hearing method or going through. When you are listening these videos, you should have your notebook, your calculator and your pen with you, and you have to hear the video bit by bit, and as you hear the video, I expect you all to go on solving the example also. Don't just take these videos as an music videos which you can just hear with your headphones. It won't be effective. So let's start with the first example. Now, these examples have been asked few times in the final exam. The most important thing about these examples is the given data has to be understood, and you should correctly analyze what parameters you have to find. The sums are very small, but the solutions are a bit bigger. So let us start with the first example. It says a small steel ball is shot up vertically with a velocity of 19.6 meter per second from top of a building. Height of the building is given as 24.5 meters. Then calculate time required for the steel ball to reach maximum height. Then how high will the ball rise above the building? Third, compute the velocity with which the ball will strike the ground. And last one, total time required for which the ball is in motion. So these four things we have to find here. So again, what is given? The velocity with which the ball will be thrown up is given. Height of the building is given. From this given data, we have to find the four required things which are asked. So let us start with the solution. So you can see the schematic representation of the diagram which summarizes this given example. Here AB is the building which has an height of 24.5 meters. At A, from A the ball is thrown up, so you have the initial velocity u at the point A as 19.6 meter per second, which is the given data. The ball reaches say up to a point C above. That height we don't know, and time required for that action to happen also we don't know. Further, when the ball reaches the maximum height At that time its final velocity v becomes 0. Okay, at that time the final velocity v becomes 0. This has to be taken into consideration. So now let us solve the example part by part, and again in the figure on the right hand side you can see the action which happens when the ball comes down is also mentioned, that is CE and ED. CE represents the height from the maximum height where the ball has reached again back to the terrace level, and ED is nothing but the height of the building, and D is the ground point. So let's start with the first part, that is motion from A to C. That is, ball is thrown from top of the terrace to a maximum height which is the point C. We don't know how much time is required, we don't know how much is the height. So firstly, initial velocity when the ball is thrown 19.6, final velocity, that is when the ball reaches the maximum height, the final velocity comes into picture, which is v is equal to 0. Acceleration due to gravity is minus 9.81. Here we are taking minus sign because the ball is moving upwards. So using the equation, v is equal to u minus gt, substituting v is 0, u as 19.6, g as minus 9.81, and t1, which is the time required for the ball to travel from A to C. So already that minus sign is taken in the formula itself. Don't put the minus sign twice, again it will become plus, or else use the regular formula u plus gt and then substitute g value as negative. Don't do it repeatedly. So in this equation only t1 is the unknown which you can find easily, that is t1 is equal to 19.6 divided by 9.81, which you get as 2 seconds. So first criteria, first thing what is asked is time required for stone to reach the maximum height. First answer is 2 seconds. Put it in a box. That is your first answer. Now next we will find the maximum height the ball reaches. We will use the relation v square minus u square is equal to minus 2gs, which is the modified equation. So here v square is 0, u square is 19.6 and minus 2 into 9.81, and here s is replaced by height term, that is h. S represents the displacement. Here we are finding the height, so instead of using the term s, I have replaced it by the term h. Therefore again in this equation only h is the unknown, and we can find h very easily, which comes out to be 19.6 meters. So second criteria, or the second thing which is asked is how high will the ball go above the building. So the ball will reach a height of 19.6 meters above the building, that is from point A to point C. Further, if you want the total height which the ball has reached is 19.6, add the height of the building 24.5, which gives an answer of 44.1 meter. Even this is not asked, but still if you want to find the total height of the ball, maximum height which the ball has reached from the ground level, you can find, and the answer is 44.1 meters. Now let us come to the next point, that is motion from C to E. Now what happens at C is the ball stops for a very minute second, or it doesn't have any acceleration. So when we are taking the motion from C to E, that is downward motion, here initial velocity u becomes 0. The time required for the ball to reach the E point, which is at same level as A, is same which we have calculated as t1, which is 2 seconds. Therefore the final velocity, that is the velocity at point E, also remains the same at 19.6 meter per second. Even if you substitute t is equal to 2 u is equal to 0 in the equation, we will get the same answer, that is v is equal to 19.6 meter per second. Now first we have analyzed A to C. Now we are coming down from C towards the building surface where the point E is there. Again I am repeating, point A and E are at the same level, hence the time which is required by the ball to go up, which is 2 seconds, is the same time which is required by the ball to come down, which is again 2 seconds only. Hence in this case u is 0, because at the starting point when the ball is coming down, initial velocity is 0, and hence as t is equal to 2, substituting we can get the final velocity, that is the velocity at E level, is equal to 19.6 meters per second. Now next, motion from E to D, that is top of the building to the ground. So here at point E, which is the initial point, the initial velocity is 19.6, and let V2 be the velocity with which the ball will come down and strike the ground. So using the equation v square minus u square is equal to 2g into s, here v square is v2 square, which we have to find. U square is the initial velocity, that is the velocity at point E, which is 19.6, g is 9.81, and s is the distance to be covered by the ball, which is nothing but the height of the building, which is 24.5. So from this we get the value of V2 as 29.41 meter per second. So the velocity with which the ball strikes the ground is 29.41 meter per second. Now for this action to take place, how much time is required? Again using the equation, simple equation, here t is unknown, v is equal to u plus gt. V we have found out as 29.41, that is V2 value. Initial velocity for this action is 19.6, g is 9.81, and this time we will take it as t2, which is unknown. So solving we get the answer as 1 second. Okay, so that means 1 second is the time required for the ball to reach from E to D, that is top of the building, to the bottom of the building. So here totally we have 3 criterias. First is A to C, which is achieved in 2 seconds. Second is C to E, which is again the top of the building, which is again achieved in 2 seconds. And last is E to D, which is from top of the building to the ground level, which is achieved in 1 second. Hence the total time for which the ball was in motion was 2 seconds plus 2 seconds plus 1 seconds, that is 5 seconds. This concludes the example. So what happens here is you have to find 3 or 4 parameters. Hence you should be able to judge which equation we have to use where. Secondly, understanding the analytical problems through video lectures at second semester level is not that easy. But what I expect is at least you try and get 25, 30, 40, 50% of the examples, so that when we restart you will not face a problem. If you have difficulties, we are open. You can call back or text at any time. Don't leave the examples as you are not understanding, because when we are in class we can come down to your desk and explain you all each problem, but here we cannot do the same. Hence please understand that we are trying to stay in touch with the syllabus and cover up the things, so that further, even if the time is not available, you should not face any difficulty. So in this example, what all we have found? Firstly, we have found the time required for the ball to reach from point A to C, which is the maximum height covered by the ball. Second point, we have found out the maximum height covered by the ball with respect to top of the building as well as with respect to the ground. Next, we found out the velocity of the ball with which it strikes the ground, and last we found out the total time for which the ball is in motion. Hope you have understood this example, let's move on to the next example. In this example, we have a particle is falling vertically under the action of gravity, which passes 2 points which are 10 meters apart in 2 seconds, 0.2 seconds. Find the height from which the particle started to fall above the higher point. So again, wordings are simple. What does the example say? A particle, say we'll imagine a ball or a stone or an object. It is falling vertically under the action of gravity. That means it is free fall. Okay, what do you mean by free fall? Just it has the effect of gravity and there is no initial acceleration given. That we term as a free fall. Then there are 2 points which we have named in the figure as point A and point B, which are 10 meters apart. That is, the vertical distance between those 2 points is 10 meters. Now that particle or that object covers the distance AB in 0.2 seconds. Now for this to happen, from what height, from what height that object has to be thrown, or from what height that object should fall, we have to calculate. So now again look at the figure. AB is 10 meters, whereas O is a point above A from which the object falls. That height is unknown. So AB is 10, AO is unknown, which we will name as H. At O, or from O, the object is falling where the initial velocity is 0. So now the total time taken by the object to reach point B is t plus 0.2, where t is the time required to cover the distance between OA and 0.2 is the time required to cover the distance between AB, which is the given data. So the total time required by the object to go from O to B is t plus 0.2 seconds, where t is the time required for completing the action between O to point A. Now consider the portion OA. Here the initial velocity is 0. So using the formula, S is equal to ut plus half gt square. S is the total distance covered between OA. We have represented it as h. So instead of S, I'll write h. U is 0 plus half g into t square. So here we get h is equal to 4.905 t square. Okay. So once we get the value of t, when we substitute in equation 1, we'll get the value of h. Next we'll come to portion OB. Now here we are not analyzing the portion AB because here we know the height also, we know the time also, but we are analyzing the entire section, that is from O to B. So the total height in this section is h plus 10. We'll put in the equation, same equation, S is equal to ut plus half gt square. Here S is h plus 10, again u term is 0, and substituting the other values. Here what is t? We have discussed earlier. T is the time required from OA plus AB. So OA we have taken as t and AB is given as 0.2. Okay, so doing the substitutions, we'll get one more equation, that is equation 2. Now substitution equation 1 and equation 2, what we get is the value of t. Okay, so what we have done here is h, what we have got as 4.905 t square. We have substituted here in which equation? Equation 2, the term h is there. There substitute the value 4.905 t square. Then take that term on the right hand side, do the calculations. and you will get the value of t, which is the unknown, which we get as 5 seconds. So this analytical part you should be able to solve properly. Please try. Still, if you don't get, you can WhatsApp the solution to me or whatever you have solved. If any corrections are required, I'll help you out. Now this value of t, which we have got in equation 3, we are substituting back in equation 1, and we get the total height h above the point A as 122.5 meters. That means we have to throw the ball from a height of 122.5 meters above point A so that it can cross AB, which is 10 meters, in a time of 0.2 seconds.